Okay, good morning. Welcome to World Forum for Women in Science 2024. We are in this technical session called Food and Agriculture today. Unfortunately, our moderators were not able to join due to some circumstances. That's why we will start our session with the first speaker for today. This is Dr. Nahla Mustafa Muhammad Ali, and I will please ask you to present yourself and start your presentation. Sorry, Dr. Ali, can you hear us? Okay, let's try maybe with the presenter, Melissa Lowe. I hope I pronounced your surname right. Okay, maybe you want to introduce yourself and to present your research.
Yes, good afternoon. My name is Melissa Lowe. I am a doctoral student at the University of the Free State in South Africa. My presentation for today is about a research paper that involves the investigation of the informal settlements in South Africa. And in the informal settlements name is Grassland Phase 4, and it's in the Free State province of South Africa. I chose this study because it appears that there is a gap in knowledge regarding the food consumption patterns of informal settlements in South Africa. Let me just share my screen. Just hold on. Can you see my screen?
Yes, we can see your screen.
Yes, as I was saying, I chose the study because it appears that there is a gap in knowledge regarding the food consumption patterns of informal settlements in South Africa, and this study seeks to raise awareness to this situation. Informal settlements are classified as makeshift dwellings that are constructed without formal planning and authorization from the government. These settlements often lack basic infrastructure and services such as clean water, sanitation, and electricity. Informal settlements typically arise due to poverty, a lack of affordable housing, and inadequate government intervention in providing proper housing for all citizens. The aim of this study was to determine whether economically disadvantaged areas, such as informal settlements, have healthy or poor consumption patterns. Informal settlements are usually characterized by low-income households and are particularly vulnerable to poor food consumption patterns. Food consumption patterns refers to the proportions, variety, and frequency with which foods from different food groups are regularly consumed. A healthy food consumption pattern involves the consumption of all the different food groups on a regular basis, whereas a poor food consumption pattern involves the consumption of only some of the different food groups. Changes in food consumption is usually influenced by factors such as rising food prices, low income, cultural traditions, and food preferences. This image is a map of Grassland Phase 4 informal settlement, which is located in the city of Bloemfontein in the Free State province. The red arrow here is where the settlement is located, and as you can see, it's quite a distance from the more urban side of the city. This image shows how the housing conditions look in this informal settlement. These housing units are called shacks. Shacks are small rudimentary dwellings that are usually constructed from cheap, readily available materials such as corrugated iron sheets and wood. These type of housings are usually very unstable and exposed to extreme temperature changes and natural disasters. For my methods, I used a cross-sectional quantitative research approach and a non-probability purposive sampling technique. The sample size was determined at 300 households. For my data collection, a structured and standardized questionnaire consisting of socio-demographic, income, and food consumption related questions. The method used to determine the dietary diversity was the food consumption score, and it measures the frequency of food groups consumed over 7 days or a 7-day period. The food consumption score uses 8 different food groups, which are weighted according to the relative nutritional value of the consumed food groups. The weights are assigned according to the nutritional density of the food group. The consumption frequencies are measured by using a 5-point category scale ranging from 0 to 4. The household's food consumption status is then determined using the following thresholds. Acceptable food consumption patterns have a score of more than 35, indicating that the households use all of the 8 food groups as shown in this table. And a borderline food consumption pattern has a score of 21.5 to 35, indicating that the households incorporated some of the 8 food groups, but not all. And then a poor food consumption pattern has a score of 0 to 21, indicating that maybe 1 or 2 of a maximum of the food groups were consumed. Then for my main findings, for my socio-demographic results, more than half of the respondents in this study were female, indicating that in many households, women were responsible for the household's food purchases, food preparation, and consumption. Research studies have shown that women in South Africa are at an increased risk of poor food consumption patterns due to a higher rate of unemployment compared to men. Then another finding was that most of the respondents occupied a shack, as shown earlier in figure 2, indicating that many households live in poor conditions and possibly did not have adequate access to proper food preparation and storage facilities. Then I found that more than 60% of the respondents did not complete a matriculation qualification, which may limit opportunities for economical growth and keep most of the respondents in a cycle of poverty. Matriculation qualification is the completion of a secondary education in South Africa. Then I looked at the combined monthly income and found that the majority of the households earned a combined income of less than 5,000 Rand per month, which is about $265, which is a very low income. A low income limits access to basic necessities and such as food, clean water, shelter, and healthcare. Research has shown that this can lead to malnutrition, poor health outcomes, and inadequate living conditions. I also looked at the main sources of income for the respondents, and a large portion of the respondents' income came from social grants in the form of child support grants and old age pension, which indicates that most of the respondents relied on the government for financial support. I also looked at the portion of income spent on 5 of the major food groups and found that a large portion of the respondents' income was spent on grains in the form of maize flour, rice, and bread, and only a small portion of the income was spent on fruit, which was a last priority for them. I also looked at the purchasing behavior, and the results showed that on a weekly basis, the respondents preferred to buy bread and milk from a spaza shop, as indicated in the image on the left. A spaza shop is a small retail shop that is usually operated from someone's house or a small rented space, and they are abundantly found in informal settlements, as they are in close proximity from the respondents compared to supermarkets. The only problem with spaza shops is that they do not stock adequate healthy food compared to supermarkets. Then my food consumption score showed a score of 32, indicating that the consumption patterns in the study were borderline, meaning the respondents did incorporate some of the 8 food groups, but not all. As you can see here in table 4, the most consumed food groups were grains and milk products, whereas the other food groups were severely neglected. I actually anticipated the score to be much lower than 32, but I do suspect that some underreporting occurred during the collection of my data due to some of the respondents feeling a little bit embarrassed to answer questions relating to low income and the frequency of consumption of certain food groups. Then, in conclusion, the importance of food consumption patterns cannot be underestimated because it provides useful information on the household's welfare, living standards, and the economic performance of a country. It is evident that in this study, the respondents relied mostly on food groups that they could easily access and afford, but they neglected other healthier food groups, thus increasing the risk of undernutrition and food insecurity. Ensuring proper access to nutritious food are crucial steps toward achieving sustainable development goals such as zero hunger, responsible consumption and production, good health and well-being in informal settlements. By fostering education and awareness about the consequences of our food choices, we can empower individuals and communities like informal settlements to make conscious decisions that align with sustainability objectives. Government strategies such as accelerating the upgrading of informal settlements, enhancing transport efficiency, and rural development can improve the living conditions of people living in informal settlements. Lastly, through collective action and commitment, we can strive towards a future where everyone has access to healthy and nutritious food, thereby ensuring a better tomorrow for future generations. Thank you so much for your time and for listening.
Thank you. If there are any questions from the audience, you can write your questions in the Q&A section, and we will check it maybe at the end of the session or during the session. If there are any questions from the speakers, also you are more than welcome to ask the question, or we can wait for the discussion at the end. Letting you know that I'm technical support from Traces&Dreams, and I will help you to moderate the session today a bit because our two moderators are not unfortunately present today. So let us check the program. And I would like to ask Dr. Nesma Zakaria Musa. Hopefully I pronounced your name correctly. If not, please let me know. And maybe you would like to start presenting yourself and your presentation. Thank you.
Okay. No, you pronounce my name in the right way. So, good afternoon, everybody. So let me share my slides. Can you see my slides?
Not yet.
Okay. Is it clear now?
Yes, we can see them now. Yes.
Okay. Good afternoon, everybody. I'm Nesma Alauddin Zakaria Musa. I'm Assistant Lecturer of Agronomy in the Faculty of Agriculture, Damietta University, Egypt. I will present my research title, Evaluation of Steam Borer Resistant Maize Genotypes for Resistance to Fowler Mealworm Infestation. We'll go through that. Maize is a vital source of food, feed, and fuel, with rapidly increasing the global demand. Maize is the third most important cereal in the world after rice and wheat. It is one of the most important cereals in Nigeria in terms of consumption and production. And not only, insect pests account for 20% loss in maize production. Fowler mealworm was the first reported in maize plants in the rainforest zone of southwestern Nigeria and in maize field at IIT Ibadan and ITNI in late January 2016. Fowler mealworm is expected to become a multi-generational based in Africa due to its natural dissemination capacity, high fertility level, good subtropical environment, large host range, and flying activities. If not regulated measures are implemented, Fowler mealworm may result in yield loss ranging from 8.3 to 20.6 million tons per year. If Fowler mealworm infests maize plants between the first and second weeks after germination, yield is lowered by 22.6%. A field is severe, infestation levels can reach 100%. In Nigeria, the Fowler mealworm is considered a new and invasive pest. Previous researches on integrated pest management techniques highly suggests using host resistance as a tool for fall armyworm. There is a scarcity of data on maize cultivars that are tolerant to fall armyworm infestation in Africa. Pre-breeding and breeding efforts should be aimed to identify promising genotypes for developing fall armyworm tolerant populations. This research conducted to 1. Evaluate maize genotypes for tolerance to fall armyworm infestation. 2. To determine the relationship between fall armyworm tolerant trait and the green yield. The research carried out in the experimental field of the Department of Crop and Horticulture Sciences, University of Ibadan. The genetic materials were 29 white maize genotypes with tolerance to steam borers were sourced from Value Seeds, Kaduna, Nigeria, which were 19 top cross hybrids, 3 single cross hybrids, 1 population cross hybrid, and 6 open pollinated varieties, which is 29 maize genotypes. This is the degrees and the materials. The experimental design carried out and happened by randomized complete block design with 3 replicates, and the experimental field was divided into 2 blocks. The first one was fall armyworm infested with fall armyworm larva imported from IITE Nigeria, Ibadan, and the other field was controlled with using insecticides, and the allele was 5 meters, and the distance within the field was 0.25, and between the field, the rows was 0.75 meters. The data collection for the traits were days to antithesis, days to sulking, antithesis, sulking interval, plant height, air height, husk cover, plant aspect, air aspect, fall armyworm leaf damage, fall armyworm cob damage, and green yield. All data analyses were conducted separately for fall armyworm infested and fall armyworm non-infested conditions using the PROS GLM procedure in SAS version 9.3. Significance was declared at 5% level of probability. Correlation analyses were also carried out separately for the fall armyworm infested and non-infested conditions on standardized data among genotypic means between pairs of traits using the PROC CORR procedure in SAS version 9.3. The base index equals 2 by G green yield minus fall armyworm leaf damage minus fall armyworm cob damage minus air aspect minus plant aspect. This measure used to identify the level of the tolerance of the genotypes. So when it is positive, that means this genotype is resistant to fall armyworm. If it is negative, that means if it has a negative value, that means this genotype is susceptible to full armyworm. So table 1 here shows means squares for analysis of variance, ANOVA table. So the upper part is for the infested genotypes, and the other is the below one for the non-infested genotypes. Okay. So both maize genotypes evaluated under full armyworm infested and non-infested conditions has highly significant difference under infested and non-infested conditions. So table 2 shows performance of top 10 and bottom 5 of white maize genotypes evaluated under full armyworm infested conditions for 2 seasons on Ibadan, Nigeria. So full armyworm tolerant hybrid 1 shows the high green yield with 5.81 tons per hectare, and full armyworm tolerant hybrid 8 shows less green yield with 3.44 tolerant hybrid tons per hectare. So for the full armyworm leaf damage, full armyworm tolerant hybrid 13 scores it was the best, so it shows like 4, but for full armyworm tolerant hybrid 5 and 8 scores 6.2. That means it is susceptible to full armyworm. So for full armyworm coop damage, tolerant hybrid 26 scored 5.7, which is susceptible to full armyworm. For the base index, the best was full armyworm tolerant hybrid 13, which is scored 8.07. And the most susceptible genotype was full armyworm tolerant hybrid 8 with negative 6.80. So table 3 performance is the top 10 and bottom 5 of white maize genotypes evaluated under full armyworm non-infested conditions, which was controlled. So the full armyworm tolerant hybrid 18 scored 6, the most the most amount of green yield with 6.85, and full armyworm tolerant hybrid 25 has 3.42, which was the less green yield. So for table 4, linear correlation coefficient for some agronomic traits of 29 white maize genotypes evaluated under full armyworm infested and non-infested conditions for 2 seasons in Ibadan, Nigeria. Infested was above and the non-infested was below. For green yield under infested conditions, green yield has a highly significant difference with positive correlation with plant height and air height, and it has a highly significant difference with air aspect and full armyworm leaf damage and full armyworm coop damage. So conclusions and recommendations: significant variability existed among the genotypes for green yield, agronomic traits, and full armyworm tolerance traits. The low mean green yield reduction of 5.1% across the genotypes indicated that most of genotypes were tolerant wear-tolerant characteristics. Full armyworm-tolerant hybrid 1, 13, 4, 10, 23, and 6 with positive base index equal and greater than 4, and the green yield greater, equal, and greater than 5.13 tons per hectare should promise under full armyworm infestation conditions and are recommended for use in full armyworm tolerance breeding. Green yield was negatively correlated with full armyworm leaf damage and full armyworm crop damage. Low full armyworm damage scores can be used to identify tolerant and high-yielding genotypes. So thank you all for your listening, and I'm waiting for your feedback or questions. Thank you.
Thank you. There are indeed 2 questions in the Q&A section. The first question would be to Dr. Melissa Loof. Maybe, to Miss Melissa Loof. Do you want to read it out, or should I read the question?
You can read it.
Okay. Have you wondered if climate change has not influenced the choice of preferred consumption of the selected group in your study? Because climate change can influence quite a lot of food availability and yield.
Yes, I have considered climate change, and I do think it definitely has an influence on food preferences. For example, changes in weather patterns may affect the availability of certain locally grown crops, leading to residents to rely more heavily on imported and processed foods. And I mean, South Africa have been experiencing extreme weather conditions like floods and droughts. Also, I think, things like economic factors such as increase in food prices due to climate-related disruptions in the supply chain can also influence food preferences in these communities. Thank you. I hope that answers the question.
Thank you. If there are some follow-up questions, please let us know in the Q&A section. And the other question would be to Dr. Musa. I will also read it out. Have you found out if there are natural ways of removing these worms from maize? Because I know Nigeria agriculture farmers look for natural remedy for worm invasion. These green worms invasive and very parasitic.
In fact, no, because all of the previous studies showed it is because this insect is new and it is spread very, very quickly, so we couldn't control it with the natural ways. So because of that, I think about to use the promising genotypes that are tolerant to steam borers, and try to test or evaluate its tolerance to full armyworm infestation. So I put the genotypes that are promising for steam borers, and I evaluated it under infestation of full armyworm. So this is, I think, a kind of like to look for another option instead of looking for the natural ways. And this is something, it is not costly and to follow this way, and it is effective. So that's what I did. Thank you for your question. I hope I reply.
Thank you. If there are any follow-up questions to this one, please let us know in the Q&A section. And let us move back to the program. The next presenters would be Dr. Nahla Mustafa Muhammad Ali, and I assume the co-presenter, Dr. Sarah Saad. Please, if you could present yourselves shortly and then start the presentation, we would be very grateful.
Hello, everyone. My name is Nahla Mustafa Ali. I'm an independent researcher. I'm Sudanese, but located in Belgium. I'm an active member of the IEEE. In 2022, I've been selected among 50 women with notable contributions. I am also a LoRa 1 expert and is chosen by the network, by the Things Network, among the top 10% of the experts.
Good morning, everybody. I am Sarah Saad, co-author of the presentation. I am Sudanese, working now in Technical University of Berlin. I'm associate research professor, specialized in soil and environmental sciences. I will start our presentation divided into two parts. I will take the first part about soil and agricultural potentiality in Sudan, and Nahla will follow up with the next presentation. Next, Nahla. The title of the presentation is Soil Quality Monitoring in Sudan. Leverage LoRaN technology. Next. Sudan is a country in Africa, in Northern Africa. Okay, most of you know Sudan. And agriculture is the principal source of income and livelihoods of 60% of 20% of population rely on agriculture potential in Sudan. Agriculture plays an important role in economic development and contributes to 30 to 35% of Sudan's gross domestic products, and 80% of non-oil and source livelihood of approximately 65% of population. Sudan has 3 distinct farming systems. This is what is important for Sudan. For crop production, we have irrigated, mechanized, traditional, and rain-fed subsectors. That irrigated, they rely on irrigating the crops and the farms from the Nile, and rain-fed depending on the rain. Other farming system, livestock and forestry, and etc. Irrigated agriculture accounts for approximately 21% of the total agricultural mechanized and rain-fed agriculture, for 6.3%, and traditional rain-fed agriculture is less than that. The main crops in Sudan is known as cotton, sugarcane, sorghum. We have a lot of legumes, fruits, vegetables, and all depend on irrigated agriculture. Historical large-scale Nile-based irrigation schemes have been a broader strategy of agricultural development. Next. This is a map of Sudan, and where we have seen the, we want to explain the where the irrigated and rain-fed agricultural farms with the dark green. This is irrigated agriculture. You can see that it all depends on lies on the river Nile and river banks. Next. What are the challenges of securing food in Sudan? Although we have agricultural potentiality, we have land, we have water, but still we have a problem of securing food in Sudan. And last report published months ago that more than 50% or 52% of population are under secure. This before the conflict. After the conflict, definitely the percentage is higher. Agricultural production and securing food in Sudan is currently facing many challenges. We have the desertification problem, especially in northern and western part of the country, soil erosion. We have irrigation problems because of a high cost of pumping water from the Niles. Soil quality, a very big problem there because there's no monitoring of soil quality in Sudan, reclamation procedures, no fertilization programs, and no harvesting, post-harvest physiology also for the crops. That adversely affect the sustainable crop production and good quality of crops throughout the different growing seasons. Climate change also have significant negative impacts on Sudan's agricultural productivity. The warmer temperature will reduce agricultural productivity by impacting crop yields negatively. Climate change and rainfall variability, water scarcity, and the inaccessibility of other water sources have contributed to crop failures, making it difficult for small-scale family farmers to maintain adequate livelihoods. Climate change and variation in temperature and rainfall during the year and during the growing seasons also affected crops and yield. Sudan currently lacks any monitoring system for soil quality. Therefore, application of Internet of Things is crucial. Sudan has a lot of potential for agricultural production. It is one of the top 10 global producers of sorghum compared to the globe. The large potential is hindered by persistent low yield in primary cereal crops compared to other countries, even the African countries like Ethiopia and other countries. Poverty rates among agricultural households are significantly higher than the poverty rates of non-agricultural households. This is due to the slow adoption of important agricultural technologies, such as the use of improved seeds, fertilizers, and other agricultural inputs and advanced techniques. Next, please. Sudan currently lacks any monitoring system for soil quality, as I have mentioned. And so that we are targeting that the application of other technologies that may improve to monitor soil quality, to improve production for sustainable production and alleviate poverty. Next, please. The floor now is for Nahla. Please, the floor is yours.
Okay. I will build upon what Dr. Sarah has mentioned. So I would focus on the soil monitoring system. So the soil monitoring system is crucial in agriculture in many aspects. For example, optimizing crop production. It helps in resource management. However, there are several requirements in the monitoring system. For example, for the area of Sudan, Sudan is 1.8 million kilometers square. So the monitoring system has to cover a vast area, and also it has to have low power consumption. It has to be cost effective, and it has to be also reliable. IoT enables all these aspects in the soil monitoring system. So what is an IoT? IoT is a network of physical devices, and these physical devices are embedded with sensors and also softwares. And in the context of soil monitoring, they enable measuring physical values and converted into data. And this data is transmitted through the telecom network, and then will be analyzed through servers. So IoT enables continuous monitoring, data-driven decision-making, resource optimization, and also early detection of issues. However, there are some requirements in the telecom network itself. So it has to cover a long range, it has to be affordable, it has to be reliable. So if we compare if we focus on the network itself and we compare wireless to wired technology, we find that wireless technology does not, in wireless, you don't have to lay cables, so it's easy to install, easy to deploy, and easy to upgrade. And if we compare LoRaWAN to other wireless technologies, we find that LoRaWAN devices are optimized to send with low power, ultra low power consumption, and to a long range. And also it enables deep indoor penetration, and it also works in a license-free spectrum, so you don't have to pay for using the network. It also enables public and private networks. LoRa devices are widely diffused. Currently, there are more than 300 million devices worldwide, and the economic value of LoRaWAN is projected to reach $46.4 billion by 2030. So it's a well-established technology. Importantly, LoRaWAN aligns with Sustainable Development Goals, in particular SDG 2 for zero hunger, and also this is a part. As a part of the soil monitoring system, it contributes to SDG 2, and on its own, it contributes to SDG 7 because of the low power consumption. With this, it aligns with the World Forum for Women in Science 2024, Science for SDGs and New Partnership for Sustainable Future. So what is LoRa? LoRa stands for long range. It's basically a wireless modulation technique that is built or derived from chirp spread spectrum. And this is the way that dolphins, bats, and whales communicate with one another and find one another. So it enables long-range transmission with low power. However, LoRaWAN is a media access control protocol, or the MAC protocol, and is developed by the LoRa Alliance in 2015 as a low-power wide area network protocol. And there are two of the main players in LoRaWAN, which are the Things Network and the Things Industries. And these enable or they provide the LoRaWAN network with servers, network servers, and also application servers. Here I will share with you an experimental investigation for LoRaWAN for soil monitoring, and the location is in a personal lab in Rijkenvorsel in Belgium. So here there is the LoRaWAN end device in a garden, and the device is connected using the LoRaWAN gateway with a sensitivity of minus 140 dBm. So the signal strength has to always be above the gateway sensitivity. As a backhaul, we used a Wi-Fi router, and it connects the LoRaWAN network to the Things Industries servers, network server and application server. So this is the performance evaluation in 9 different positions, and here we measured the we measured the received signal strength and the signal to noise ratio and time on air. So the received signal strength shows the strength of the signal received by the gateway, and as I've mentioned, it has to always be greater than the gateway sensitivity. As the signal to noise ratio is the quality of the signal, and the time on air shows the delay on the signal. We tested indoor and outdoor positions with worst case scenarios. So these are the results. The first figure shows the received signal strength for the 9 positions. And as you can see, it's always greater than minus 70 dBm, which means that the gateway will be able to receive the LoRaWAN signal. And also the quality of the signal is 10, signal to noise ratio is 10 dB. The time on air is always less than 1.6 seconds. Of course, it differs based on the position of the end device, based on the obstacles, but all the readings are below 1.6. With this, we can conclude that soil monitoring plays a vital role in optimizing agricultural practice. The integration of IoT technology revolutionized soil monitoring, and LoRaWAN offers extensive coverage with minimal power consumption. We mentioned also that LoRaWAN aligns seamlessly with the Sustainable Development Goals. We demonstrated the feasibility of soil monitoring using LoRaWAN, and with this we suggest leveraging LoRaWAN technology for soil monitoring in Sudan. The challenges could be the political will and the conducive environment. So thank you very much, and if you have any questions, you are more than welcome.
Thank you. There are no questions in the Q&A section. Let me go back to the program. Maybe if, some audience want to write the questions, they do have time for it. If the speakers have questions to each other, that would also be great. And unfortunately, the last speaker, Dr. Lai is not able to present because of the poor connection to the internet. And there are no questions in the Q&A section. So if you have any remarks, you can give your remarks or comments now. Or if no, then we will have to close the session. There is one question in the Q&A section, please pictures. If it refers to the pictures of the presentations or the session, then I have to say that all sessions are being recorded, and we will be able to upload the sessions on Facebook, so you can follow up. If there are no questions, then I want to say thank you for your invaluable contribution, and we can close the session. I wish you a nice day. And goodbye.
Okay, bye. Thank you very much.
Thank you very much.